Before we move on with logarithms, we really need to talk about the number e. As you know, pi is an irrational number, right? Pi is approximately 3.14, right? That's pi on a number line. E is approximately 2.7-ish on a number line. So they are real numbers and they are irrational. And E can be explained a couple different ways. I like to use the factorial definition. By definition of a factorial is the exclamation point. It's any number times all the whole numbers below it down to 1. So basically, if I said 5 factorial, that would mean 5 times 4 times 3 times 2 times 1. So you have the factorial button on your calculator if you want to try to find it. It is an exclamation point. Now, on my graphing calculator, I have to hit the math button, and then I have to go over to probability, PRB, with the right arrow, and then I go to number 4, which is the exclamation point. So that's how I find my exclamation point. You should take a minute now to see if you can find yours on your calculator. If you found one on your non-cell phone calculator, you can do 1 divided by 0 factorial plus 1 divided by 1 factorial plus 1 divided by 2 factorial. And that should give you an exact number of 2.5. Because by definition, 0 factorial is 1, 1 factorial is 1, and 2 factorial is 2. So 1 plus 1 plus 1/2 is 2.5. So if you were to add 1 over 3 factorial, which is 3 times 2 times 1 is 1/6, you would get 2.6 repeating, or 2 2/3. And if you go to infinity, if you really you just keep adding and adding, you get closer and closer to the actual number 2.7. Okay, so this number 2.718 we can actually just write as, let's pick a new color, E. Okay, so E is 2.7-ish, and this is one way to see that number E. So if I were to start using E, let's go back and say if I want to say 2 to what power is equal to 32. You should think about saying 2 to what power is, well, 32 is 2 to what power? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 to the 5th is 32. So if 2 to the x equals 32, then that means 2 to the x equals 2 to the 5, which really that means in a sense, you can just kind of cross out the bases and be left with the power equals the power, no matter what the base is. So even if it was e to the x, let's say equals e to the x squared plus 2, you can already see you have a base, right, equals a base. So if a base equals a base, you can basically cross it out and just say the power, I forgot, I was supposed to write x squared plus 2, sorry. Start over. If e to the x equals e to the x squared plus 2, if the bases are the same, you can say the powers are equal. X equals x squared plus 2. Now, do you remember how to solve a equation with a square in it? You can solve a quadratic equation by setting it equal to 0. So by moving everything to one side, I prefer to keep the x squared positive. Solving quadratic equations with squares in them, the best thing I can do is solve by factoring if I'm lucky. So I'm going to use x and x for x squared, and I can only use 2 and 1 to make a 2 in my products. And then my inners have to make -1. And so for my middle ones to make -1, I'm going to say use -2 with +1. And you FOIL that out to check. So it looks like there's actually 2 answers here. When x is 2 or 1, you can go back to the problem and say e to the x equals e to the x squared plus 2 when x is either a 2 or a 1. So, did you find e on your calculator? Try to do e to the 2nd power. Eventually, we're going to take, what we should do right now actually, is look at that equation. So, if I were to say 2 to the x, you guys are already supposed to know what that looks like. Exponential model in the form a b to the x. Looks like the a is 1 and the b is the 2. So the initial value would be 1, and it would move twice as fast off the asymptote every integer. Twice as fast. So we already know 2 to the x with an asymptote at the x-axis. And we already know 3 to the x. Right? The a value would still be 1, and the b value would now be a 3. So you're still starting at 0, 1, but you're tripling the heights every time. Triple and triples off my charts. So we already know this about 2 to the x and 3 to the x. So now we can talk about e to the x. E to the x, e is just a number. So the number in front of e is a 1. And now the growth factor is e, which is 2.7-ish. So you're still starting at 1, and you're basically going to have a graph that ends up being in between the two, because here's 2.7, and this is where I wanted to see what e squared was. So if we want to really go back and just talk about some ordered pairs, if you're stuck with a graph, don't forget you can always plug in points. Now, e to the 0, anything to the 0 power is 1. E to the first, I'd rather you just leave it as e, because we know e now is 2.7-ish. E squared, I'd almost prefer you leave it as e squared, but you have to know what it is on your calculator. So go ahead again now and try to make sure you can do e squared and see what you get on your calculator. So it looks like you get 7.3-ish. So I want you to memorize that e is 2.7-ish, and I want you to memorize that e squared is 7.3 or 7.4 if you're going to round. That is not as important at this point. So the reason why I'm saying that is because now you can have this lovely graph of e squared in between the other two.
I mean e to the x.
Knowing the e graph is going to be important to us. It's called the natural number e.